The amount of time to complete a physical activity in a PE class is approximately normally distributed with a mean of 36.7 seconds and a standard deviation of 7.7 seconds. What is the probability that a randomly chosen student completes the activity in less than 31.5 seconds? So since this is a normal distribution, I'm going to try to sketch here the shape. So here is the normal distribution. The mean is in the middle, we know that, and the standard deviation is given. So to answer the first question, what is the probability, that means what is the area under the curve, that a randomly chosen student completes the activity in less than 31.5. So 31.5 is approximately here. This is 31.5. And less than means the area below. So I'm looking for this area that I'm shading right here. And I know that the normal distribution function computes the area under the curve to the left of a specific given number. So that is what I'm going to do to answer that question. So here we go. Equals norm dot distribution of 31.5, comma, the mean 36.7, comma, the standard deviation 7.7, comma, true. So that is the answer for the first part. This is the answer for the first part. Okay. So what goes here is 24 point, or 25%, you could say. But your answer should be in decimal form, so 0.2497. What is the probability that a randomly chosen student completes the activity in more than 42.9? More than 42.9 means it's the area above a certain number. 42.9 is approximately here. It's a little bit above the mean. This is 42.9. And above means, or more than means the area above. We know that the normal distribution doesn't compute the area to the right, but we know also that the entire area under the curve is equal to 1. So if we say 1 minus the area to the left of that number, it's going to give us the area to the right. So that is how we're going to do it. We're going to say this is equal to 1 minus norm dot distribution of 42.9, comma, the mean, which is 36.7, comma, the standard deviation 7.7, comma, true. And that is going to be the answer. So it is 0.2104. So 0.22. I don't know why it's not writing. Try one more time. 2104. That is a 0 and there is 1. What is the probability that, what is the proportion of students that take between 30.3 and 41.3 seconds to complete the activity? So this is the area in between. The proportion is the same as the probability, is the same as the area under the curve. So between 30 is below the mean. So that is the first number. And 41 is above the mean. Just because it's hard for me to write, I don't have the right tools to do it, I'm going to highlight between those two numbers. So I need to find this area in between those two numbers, which is 30 and 30.3 and 41.3. I'm going to name this X. I'm going to name this Y just for the sake of... So here is X. And here is Y. Okay, notice how y is bigger than x, which means if I could find the area to the left of y, the entire area to the left of y, and then find the entire area to the left of x, and say the yellow area minus the blue area, which now turned green because of the mixing of colors, then I will get the area in between x and y. So that is exactly what I'm going to do here. So first I'm going to find the area to the left of y. So equals norm dot distribution of 41.3, comma the mean 36.7, comma standard deviation 7.7, comma true. And then I'm going to find the area to the left of the smaller number 30.3, which is x. So I'm going to say norm dot distribution of 30.3, comma the mean 36.7, comma standard deviation 7.7, comma true. Now this is the yellow area. Let me actually highlight it correctly. Just remove that. Okay. So this number represents the yellow color. This is the yellow color. And then this number, the second number, represents the blue color. If I take the yellow, the entire yellow, which is all of this area, and subtract the blue color, I'm going to get the area in between. So I'm going to compute it. That is the yellow area minus the blue area. It's going to give me the area in between, and that is going to answer the last question, which is going to be 0.52, not the last question, but part C. So let me actually write part C here to make my life a little bit easier. So part C, that is the answer. This is part A, and this is part B, instead of writing the entire number. The last part. 85% of all students finish the activity in less than how many seconds? So we have the probability, or we have the percentage, and we need to find the cutoff for that percentage. So this is what we have. Visualizing is very important in these types of questions. 85% of the students, so 85% is approximately all of this area. It's more than half, so this is 85%. Okay, and we need to find the missing number here, or the cutoff for that area. This is exactly what the inverse function does. The inverse function does what the distribution function does. So if we had x and we wanted to find the percentage, then we would have used the distribution function, norm distribution. But if we are given the area or the percentage and we want to cut off, we want that cutoff, which is the x, then we're going to use the norm inverse function. So this is part D, and part D goes like this. The inverse function requires the area to the left, and that is exactly what we have. So we're going to say norm dot inverse of the 85%. We're going to type it as a probability or as a decimal number, 0.85, comma the mean for this distribution is 36.7, and the standard deviation is 7.7. And then there isn't a cumulation option, because this uncumulates what the other function does. And the answer is about 44.7 seconds. So that is the answer for the last part, and it does make sense because it's above the mean, which is 36.7. So that number definitely makes sense. I hope this video helped you, and I will see you in a different one.